My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 441. In this lecture, we will try to understand Sift. So, one very popular algorithm to featureize images is called Sift. Sift stands for Scalar Invariant Feature Transforms. This is extremely useful for detecting objects in an image. It's very popular for detecting objects in an image. This algorithm was designed in 1999. Sift is an algorithm in computer vision to detect and describe local features in images. What does is this? Let me show an example here. The way it works is as follows. Let's say here you have an image. Just see these images. What Sift does is it detects first key points. It detects first key points. Typically, it detects key points like key points are mostly like corners, which are easy to detect. For every key point, it creates a vector which is of 128. Just see here, it will identify key points for each key points like this, for each corners like this. It will create 128 dimensional vector, isn't it? These are the key points. These are corners. Here a corner. This one is corner. For all corners, it will create a vector of dimension 128. It is a real vector, of course. It creates 128 dimensional vector for each point. Just see, here I have a corner point for which it will create 128 for all corner points, for all key points like this. Yes, for each of the key points, Sift actually computes. Sift actually detects key points and it computes 128 dimensional vectors for each of the key points. Now I have complex image. Just see, this is one complex image, isn't it? I have one complex image like this. This is an image where I have three images. Just observe here, in this image I have three images. What are they? Just see, this is image 1. Let me say object 1. This is image 2, object 2. There is another image. This is object 3. Three images, or I can say three objects. I have these three images. If you observe carefully, third object means this object. Third object is partially visible. First object is not fully visible. Just see, this is first object which is not fully visible, isn't it? There is a lot of other background. Just see, here I have background, here also I have background, isn't it? Now lot of background stuff here. Now challenge is this: if I want to detect this image, if I want to detect this image here, if I want to detect this image, suppose if somebody gives me this photograph, this photograph is given, you have to detect this image. That is our challenge. Suppose now challenge is this: if I want to detect this image, suppose if somebody gives me this photograph, this entire photograph, isn't it? These are two images. This is first image, this entire one is second image, in which you have three objects or three images. First one is called query image. What is this? This is known as query image. This image is known as, the second one is called, this is database image, isn't it? Somebody might click second picture, somebody might click this second picture and say, can you detect what objects exist in this? In your database, if you already have first image, this is first image, in your database, if you already have this image, that is first image, and if you already compute the features means key points, this image now can be represented as a combination or set of the features. Here let's assume I have 10 features. Let me assume I have, let's assume I have 10 features. Here now I can represent this as, how can I represent these features? I means image, this particular image I am representing using 10 features, v1, v2, so on v10, v1, v2, so on v10 are vectors. I can say they are vectors. Again, each of the vector is 128 dimensional vector. Now this whole image can be represented, this entire image can be, the whole image can be represented as a set. Now I will try to find these 10 features. If they are available, if these 10 features are available, if they are available in second image, now all the 10 features, if these 10 features, I am checking if these 10 features are available, I will say, since they are clearly visible, since they are available, probably somewhere here is my object, isn't it? This object of somewhere here of my object of interest, isn't it? Somewhere here I am trying to find this particular image here. This is somewhere here my object of interest. So Sift is very popular algorithm then is being used. This particular Sift algorithm has been used in image search. So this technique has been extremely popular in image search, and variations of Sift have been used extensively. For example, if you go to Amazon.com, let me assume if you go to Amazon.com mobile app, if you take their mobile app, there is a very nice feature wherein if you have a book with you, you can take a picture. You can take a picture of your book cover and you can search using it. When you search using this, it recognizes what the book cover is. Because let me assume this is book cover. Because in the database, in the backend database for Amazon, you have every book, you have image of book cover. So what they do here is, from the image that you gave, from the photograph that you gave, that a picture you took from smartphone, they actually detects all the key points and now ask the question, where are these key points in the whole my repository, of books, isn't it? In this book, if these things are matched, if these key points are matched, if these things are matched very well, they will say, okay, this photograph very well belongs to this particular photograph, very well belongs to this particular book. This is actually used, by the way. You actually go to Amazon.com mobile app, there is actually a search button using a photograph. It uses variation of Sift, not exactly Sift itself, because Sift has some computational issues because it is too slow. It takes too much time to compute. There are variations of Sift which is exactly what are used in technologies like this, wherein you take the photograph of book cover and it will recognize what is the book cover is, what is the cover image, which book does this cover image belongs to. It is very popular technique, very popular way of featureizing the data. As you see, name itself called scale invariant feature transform, because here I have bigger image. Just see here I have bigger image. Just observe this one. Here I have bigger image, isn't it? And here I have smaller image, isn't it? I have smaller image here, isn't it? Yes, I will repeat. Just see, I have bigger image here, I have smaller image of some object. So scale invariance basically means these features would not change much. Scale invariance basically means, what is the meaning of scale invariance? These features would not change much, even the size of the image is changed. Features will not change much, even the size of the image changed. That's what it is. That's what it is called, scale invariance. Scale invariance basically means, invariance means does not change much. These features, whether your image is very big or it is slightly small, that's important. Whether your image is very big or it is slightly small. This is big image, this is small image, isn't it? It's very big or small, slightly small. The features do not change. That is important. I will repeat, whether your image is very big like this and very small like this, isn't it? It's slightly small. The features do not change. The features do not change much. That's what it is called, scale invariant. Sift also has something called rotational invariance, isn't it? What it means is, here is your image is like this. Just see, this is your image is like this. In the second figure, same image, just see, in the second figure, same image is rotated slightly. If you look at this, just see this one, isn't it? So your initial image is like this. It is rotated slightly here. It is rotated slightly. It has changed the scale. Scale change basically means it is smaller, isn't it? It is smaller. The second one is smaller than first one, isn't it? Additionally, it is rotated. Second one is rotated slightly. So Sift has both of these nice properties called scale invariance and rotational invariance, which means the features that you compute do not change much, whether actually image has shrunk in size or whether it is rotated slightly. Of course, for huge rotations, it may not work well. So when the image rotates, it still works well. Features are stable. So if you want to compute Sift features, there is a library called OpenCV, Open Computer Vision. OpenCV means Open Computer Vision, which is a very popular library for processing images. So in OpenCV, again OpenCV has Python interface. So whenever you want to compute Sift features for a given image, you can obviously use OpenCV, which has a Python interface. You can write Python code, read it to OpenCV to detect Sift features. Just see Sift 2. Just type this one in Google search. Just in Google search, write Sift to OpenCV Python, isn't it? And this is very easy. You very easy you to figure it out. All you need to say is type Sift to OpenCV Python in Google. The three keywords. What are three keywords? Sift to OpenCV Python. three keywords and you will get there is a lot of documentation for OpenCV, and you will get very simple code to do it. It is not at all rocket science. It's a very simple. It explains how Sift works. Import, just say import CV2. Just say this one. What it says, just observe this one. Import CV2. It stands for OpenCV. You are reading an image. CV2.imread. You are reading an image, isn't it? What is it? You are converting image from color to grayscale. Just see, from color to, you are converting image from color to grayscale. Then you are saying, I want to create Sift features. Just see, I want to create X features, Sift features, and I want to detect Sift features, isn't it? Just see, I want to detect Sift I want to detect Sift features, and you are drawing the Sift features. Just see, you are drawing the Sift features on the image, and you are storing the final image, isn't it? And you are storing the final image. So it is literally like 5 or 6 lines of code to get Sift images today using OpenCV. So any of you are interested to get Sift features, just Google it up. Extremely easy to get all of these code snippets that you can reuse. Just go through this lecture. In my next lecture, I will discuss about deep learning features, convolutional neural networks. Thank you.